Alright, so on this section of the lesson, we're going to be talking about a cube root function. Now, the cube root function, unlike square root function, is to the third root instead of the second root. And the parent function is y equals the cube root of x. Now, the cube root of x is the same as y to the 1/3 power. Okay, so those are the same thing. They can be used interchangeably. Just be aware of that. So similar to the last one, the a value determines the stretch, the compress, and the reflection factors. The h and the k represent the vertex, similarly to just like on the last set. And number 7 is what's really cool about cube root functions. The domain and range is always all real numbers. So you don't have to worry so much about that like you do with the square root function. So let's get started. Analyze f of x is equal to the cube root of x plus 1 or cube root of plus 1. So to find the vertex, just like you find the vertex of the original square root functions, you change the sign of the x and you keep the sign of the k. And in the case that you'd have to factor out a -1, that's only when the x is negative. Okay. Now the domain is always all real numbers, and the range is always all real numbers, so nothing to worry about there. To find the root, you're going to replace f of x with 0. I'm going to subtract 1 on both sides. That gives me -1 is equal to the cube root of x plus 1. Now, cube roots can give you negative results, unlike square roots, so you don't have to be alarmed here. Does anybody know how to cancel out a cube root? Put it to the third power. Very good. So this would become x plus 1 is equal to, what's -1 to the third power? -1. Subtract 1 on both sides, which gives me x equals -2. So I just erased that for room. So our root is -2, 0. Okay, so moving on. Now we are going to identify and plot this. So you're going to plot your vertex, which is at -1, 1. And then you're going to plot your root, which is at -2, 0. And you usually are going to want one more point on this graph. So the easiest one to always find is the y-intercept, okay? So how you find a y-intercept is you just replace x with 0 and see what happens. So we get the third root of 0 plus 1 plus 1. That's just the cube root of 1 plus 1, which is 2. So the way that these graphs look, it's like this. It's like this wavy shape. It's a cube root function or a cubic function on its side. Okay, that's how what the graph looks like of it. Now, if we read this graph from left to right, does this graph ever stop increasing? It's always increasing, right? It's increasing at different rates throughout, but it's always increasing. So this graph is increasing forever. Is it ever decreasing? No, never. So it's always going to be either always decreasing or always increasing based on how it looks. Now the end behavior, as my x is on the -infinity side, my graph would be going down to -infinity. And as my x is on the positive infinity side, my graph is going to positive infinity. Just like that. Any questions on the cube root functions? These are a little easier. What do you guys think? Easier than square roots? Okay. You guys ready for the next one? Alright. So the next one says to analyze. So this one, okay, has a little bit more going on. What's the vertex of this one? Good, 2, -1. Domain and range are both negative infinity to positive infinity. So the vertex is right here, 2, -1. And to find the root, you're going to set f of x equal to 0. We're going to add 1 to both sides. That gives me 1 equals negative cube root of x minus 2. Divide by -1. And we get -1 equals the cube root of x minus 2. Now remind me, how do I get rid of the cube root?
You have to third it.
Yeah, put it to the third power. 1 to the third power is just 1. -1, I'm sorry. -1 to the third power is -1. And this just becomes x minus 2, which means x is equal to 1. Is that correct? What do you guys think?
Yeah.
So my root here, and I kind of run out of room, so sorry it's messy, is 1, 0. So you guys can practice finding that. Now, is this graph, well, we haven't looked at it yet. Let's not get ahead of ourselves. My root is here at 1, 0. Now, I know that if I plug in 3, I'm going to get another easy point. So if I plug in 3, 3 minus 2 is 1. Cube root of 1 is 1. -1, that's going to be 2 right here. So you just plug in a point to find it. And they always have this shape right here. So you're going to start recognizing this more often once you start seeing these. But it's going to have this shape right here. So I just found this point by plugging in 3 in for x. And it's always going to have that mirror reflection over the vertex. You kind of start seeing the pattern. So is this graph ever increasing from left to right? No. But it is always decreasing, right? And its end behavior, as x goes to the negative infinity direction, my function goes up. And as my x goes to the positive infinity direction, my function goes down. Like that. So I will pull these up quickly on Desmos to show you what they look like. So this is the cube root parent function, okay? Now this particular function looks like this. So as you guys can see, it's what we just graphed, okay? So you can always check your work on Desmos as well. So that's all I have for you today.